It's amazing to see so many of you here. It's last year was quite packed, but this year it's even bigger. I think you've seen the numbers that Nick showed earlier, and it's quite impressive. We also see so many people joining on the stream online, and it's just amazing to see how much the Flower community has grown since last year. Today, I think many of us, in many of the conversations that we had, I think many of us are here because we are excited and interested in where AI is going in the future and what the future of AI actually looks like and how we can build it together. And I think an interesting way, an interesting perspective to try to predict where the future might go is to actually look at the past and see how certain things in the past have played out. So one of the angles, one perspective I find particularly interesting is if we look at the history of computing, we had this era of mainframe computing. And if we look at the characteristics of mainframe computing, it was those everyone was trying to build a bigger system, and these systems, they were isolated. There was no connection between these systems. Everyone just tried to build a bigger system. They were mostly proprietary, so they were under the control of the manufacturer, and you either had access to one of these systems and you could use them, or otherwise there was just no way for you to participate in this era of computing. Now, as we all know, everything changed with personal computing and the internet. And one way to frame this is to sort of call this the networked era of computing. And if we look at the characteristics of this, it looks very, very different. It's fundamentally, it's smaller individual units, and these smaller individual units get really powerful because they are connected. They're not isolated anymore. They talk to one another using open standards. Everyone can participate. Everyone can get a personal computer. Everyone can customize the computer. Everyone can run the software they want to run. This is also when we saw the advent of open source software, and fundamentally it's decentralized in nature. Now, if we look at the future of AI, if we look at where AI currently is and where it might go, I feel a little bit like we're almost in a mainframe era of AI. Everyone is trying to build a bigger and bigger cluster. These clusters are essentially isolated. These clusters are not talking to one another. The only way to participate is really to call an API. This is how still many, if not most, of the AI systems we all use today are built. Your device has a little bit of data on it, and all of this data goes to an API, and then behind that API, usually there's a closed source model, a proprietary model. And if we compare that sort of to the history of computing, then probably the next slide is quite obvious. I think the future we want is a future where it's easier for individuals to participate, easier for different organizations to participate, and a future that is not as isolated as the current one, but one that is more connected. So this future could, one way to frame this future is to call it the networked era of AI. It's fundamentally decentralized. It needs to be built around open source software and open standards. It's to enable this connection. It needs to enable individuals and organizations to run their own models. And essentially, it puts the user and individual, also smaller organizations, back in control. So it's open to participate, and it's fundamentally decentralized in nature. Now, one of the key ingredients we need to make this future happen is really the capability to run AI models on a device. But if any one of you has ever tried to get a model and run it on a device, especially if that device doesn't run Python, if you're talking about mobile devices or so, you probably ran into quite a few challenges. The first challenge you often run into is you have to use quite a complex tool chain to actually take a model and then convert it and understand quantization, things like that, to get it to actually work on a device. And don't get me wrong, these toolkits that we have, they're amazingly powerful. And if you're interested in this space and you know all the dials you can turn, they can give you great performance. You can take a model, you can optimize it, you can play with the quantization and things like that, and you can get great results. But it's not something that the average application developer who essentially just wants to integrate an LLM into their app, it's not something they want to spend their time on, actually. Another challenge, if you've ran through this entire process on the previous page, if you've ran through this process, you get one model that works very well on one device or a small family of devices. But there's so many different devices out there that if you want to do this, if you want to support all of these, and if you have a large user base with a diverse set of devices, you'll have to go through this process over and over again. Now, this is where our most recent announcement comes into play. 2 weeks ago, we announced the preview release of Flower Intelligence. And here's Charles to tell you more.
All right, thank you, Daniel. So yeah, Flower Intelligence, we believe this is very important to make sure that local AI can be democratized and used everywhere. Our goal essentially is to make sure that it is as easy to run local AI as it is currently to open up a browser and just go to a cloud provider. So the first step is, of course, building an open source tool for this simple on-device AI inference framework. And it was very important for us to make sure that the APIs were very simple to start with. Of course, you can get more complex if you have more complex needs. And also, we wanted to keep this compatible with current existing APIs. So, for instance, if you're running something with a cloud provider, you can just switch a single line and essentially run locally. And one very important aspect of this, as Daniel mentioned, is that if you have different platforms, it might be very annoying to switch your code in between. So we wanted to align our APIs for multiple languages and essentially make the framework fully cross-platform. One other aspect is the model support, and this is something we realized the hard way while implementing the framework, is that sometimes you might find a great model on some device, and on another device this might not be compatible, and you might struggle to find a version that works. And so we curated a list of diverse models, tested them to make sure that on all the devices using our framework, they were working. And we also have some very small models and some bigger ones. And if you're still doubting the power of on-device AI, please let me change your mind with this amazing demo that you might have seen running there, actually. So this is currently running the biggest version of the DeepSeek R1 model. So in this case, this is 685 billion parameters. You can actually see, maybe it's a bit small, but you have all the RAM it's taking in memory. And obviously, so this is running over there. Feel free to test it out, to make some queries. Yeah, I think it's running pretty great for such a big model. So this shows the power of local AI. And in the cases where, I don't know, you're working on some different tasks and your machine doesn't necessarily have all the resources available to run such a big model, it was very important for us to have seamless support for what we call remote handoff to Flower Confidential Remote Compute. And so in this sense, the goal is that when no resources are available, the framework will automatically hand off, if this is enabled, to a remote server. It's all end-to-end encrypted. So because it was very important for us to keep the privacy aspect of this. And so this way, when you are working on your app, you don't need to worry about the hardware requirement or of a specific user or another. And so, yes, as a summary, this is what Flower Intelligence is. It's a local-first AI open source framework with optional Flower Confidential Remote Compute. Thank you.
Thank you, Charles. While working on Flower Intelligence, we've been working with one company that probably all of you have heard of and know pretty well. It's a company that has probably the highest standards when it comes to protecting user data. And that company is Mozilla Thunderbird. So they have an extremely high standard for protecting user data. And the traditional approach of building AI systems, just taking the user data and sending it to some third-party API was just completely out of the question and would have never worked for them to build a system. Let's hear from Ryan.
Hello, everyone. I'm Ryan Sipes, Managing Director of Product for Mozilla Thunderbird. Now, for those of you who don't know, Thunderbird is the world's most popular open-source email client with over 20 million users. And as you'd expect, those users are very privacy conscious when it comes to their email data. What is interesting about our partnership with Flower is it allows us to ship AI features that respect user privacy. And that's why we're continuing to partner with Flower on the next generation of Thunderbird.
We're super excited to be working with Thunderbird. The Thunderbird team has been amazing to work with. Together we show what a different way of building AI systems can look like, and you can actually try it out right here. Please definitely check out the demo that is on the demo table over there. So if you are also interested in working with us, if you're interested in pushing the boundaries and work with us to try out how to build different kinds of AI systems with a local first AI approach, I have good news. The Flower pilot program, batch 3, is officially open. You can apply to become part of the program on flower.ai/pilot. That's it for Flower Intelligence. So you've seen Flower Intelligence, the preview release. It's on-device AI with optional confidential remote compute. It's our contribution to in working towards this vision of making networked AI a reality. And there's preview release SDKs available already. And if you want to work with us, I can encourage you to go to flower.ai/pilot. With that, we're moving into the next section, which is about, obviously, the Flower framework. So since last year, since Flower AI Summit 2024, we had 15 releases. And all of these releases, we've been slowly rolling out Flower Next, and we officially completed this transition to the Flower Next architecture, which is a very fundamental change in the Flower framework. So with this new architecture and with all the new features that we have in place, the new version of Flower should actually be called Flower 2.0. But what we call it is not 2.0. We call it still Flower 1.17 because it's fully backwards compatible. So everything you've built with Flower 1.0, you can still run it in the version that is released today. A big effort towards getting us getting all the processes that are behind the Flower development into just a very professional state and into becoming more enterprise ready was actually to get ISO 27001 certified. So this was a process that we completed very, very recently to make sure that all the processes we have are ready and compatible with enterprise requirements. And if you want to learn more, go to trust.flower.ai. And I want to extend at this point a huge thank you to the team. The entire team has done an amazing job. When we started this process, we were told that it would take us 18 months to get certified, and the team did it in less than 3 months. So I think that deserves... So let's go into some more details about the Flower framework, and here's Javier to tell you more.
Thank you, Daniel. So we have some amazing news about the Flower framework. After all, it has been 12 months since the last Flower Summit, and the first piece of news is that we don't want to call it a framework anymore. Instead, we're going to call it platform, and this is because Flower has really evolved from being an amazing toolkit to do federated AI for any workload and any use case you might have into a really powerful framework. Platform, sorry. And now, still switching. And now it is so much easier to have multiple federated learning apps and workloads running in parallel. This is what we call multi-run. We have introduced a powerful command line interface, so you can submit your runs, see the status of your runs, get the logs, no matter where they are running on, and many more features. There is also built-in user authentication, so only those that are authorized to submit jobs to your federation can do so. And there is also different forms of node authentication, so those partners that are joining your federation, you can be sure that they are who they say they are. There is also a much improved support for running Flower in production. So we are now creating official Docker images, and also there is improved support for Kubernetes. And you will hear more about this tomorrow morning in another talk about Flower being ready for enterprise. So don't miss that. And finally, and this is a big one, we have introduced a new API that we call it the Message API. You will learn more about it later, but some of the things this enables is a new set of privacy-enhancing technologies. We have improved our differentiable privacy support, as well as secure aggregation. There is also great support for homomorphic encryption, and you will be able to see some examples on how to use it with Flower very soon. And the Message API also enables you to implement custom SMPC protocols, because the Message API is so much more versatile than what you can currently do with Flower. And of course, you can keep still using Flower mods. Many of our partners and collaborators have already been using the latest features in Flower in the recent months across multiple sectors, like including finance, with Banking Circle, health, with collaborators from Broadcounts, and of course, Mozilla Thunderbird. And you will hear more in detail about all of this and many more tomorrow and later today. Throughout these collaborations, we got some super amazing feedback that we have distilled into some components that can be integrated with the core framework in Flower. These are a bit opinionated, but we think that brings some capabilities that are really important for enterprise and pro users. For example, OpenID Connect, so you can plug your authentication endpoint, or audit logs, so you know who submits which run and where it runs. And you can implement traceability features, for example. Or you can have Postgres integrated right in your Superlink. And there is one more, and I think this has been requested by many of you that I can see here. And yes, there is a dashboard coming to Flower. You will be able to see your supernodes, you will be able to see your runs, you will be able to see your logs, and many more features that will be announced in the coming weeks and months. And this is just a sneak preview about the Flower platform, and you will hear more about it in a couple of hours in my talk. So see you there. Back to you, Daniel.
So over the past couple of months, we've been working with one company that I'm sure everyone who's worked in federated learning has heard of. That company has been building FL system even before most people have heard about FL ever. They showed what's possible with federated learning in healthcare. And most recently, and this is where this picture comes in, President Emmanuel Macron from France even recognized their accomplishments at the Paris AI Action Summit. And the company I'm talking about is obviously Owkin. So, Guillaume, come up to this there.
Yeah. Okay. Well, thanks. For the one who don't know about Owkin, Owkin is a company working on understanding complex biology through AI. I don't think I need to explain to you what are the application of federated learning in healthcare. We had so many great examples this morning. Owkin has been a pioneer in federated learning in a way that we use in real-life research project for more than 6 years. And today, we are excited to announce that we are partnering with Flower to support us delivering federated learning on different projects. And if you want to learn more how at Owkin we use federated learning on research projects, you can go to our talk tomorrow at 4:45, I think, with Hanka, my colleague, which is hiding by there. And thanks again, Daniel, for inviting us.
Thanks, Guillaume. We're super. Thank you. We're extremely excited about this partnership and to help Owkin bring federated learning to even more users in healthcare and biotech. Now, I want to talk a little bit about the Flower ecosystem and the ecosystem that has been sort of evolving around Flower over the last year. As you probably all know, Flower allows you to practically bring all the tools you know and love from just regular centralized data science and then just plug them into your federated workloads. You can use any machine learning framework like PyTorch or TensorFlow, other logging libraries and things like that. But one part that sort of almost held back the federated learning ecosystem a little bit, or the adoption of federated learning, was that it was quite difficult to choose sometimes for users between one federated learning solution or the other. So ideally, if we look at the workflow that an individual researcher or AI engineer wants to go through when building a federated learning system is, you want to build your app, and then usually the first step is to try this out. This is where the Flower simulation runtime comes into play. You want to try it out on your local system or maybe a bigger simulation cluster. Now, if you want to move this to production, you'll want something like the Flower deployment runtime. In the deployment runtime, ideally, you don't want to make any code changes. You just want to take this app and move it over to the deployment runtime. Now, there's also a great ecosystem of platforms and other federated learning solutions, and sometimes you just have requirements that are better met by these other systems. So ideally, what you would like to do is you would also want to be able to run the Flower app on third-party runtime. Now, We've been working over the last year with a number of organizations, and I want to highlight a few of them to make this actually happen. The first one, as you probably all guessed, is NVIDIA. So last year at Flower AI Summit, we announced our partnership with NVIDIA. Holger was on stage and showed a very early demo. Over the last year, we worked incredibly hard to ship this. We actually shipped multiple versions of this. And you can now use it. You can use it in Flare 2.6 and the latest version of Flower, and they just work together pretty seamlessly. Make sure to check out Holger's talk tomorrow to learn more. The next company I want to talk about is Intel. Intel was one of the early pioneers in federated learning. They've given talks at past Flower AI summits. And Intel has been doing great work when it comes to standardization in federated learning and also confidential compute on Intel SGX. Patrick is here to tell you more about this in his talk tomorrow. Another fairly recent announcement we made is our partnership with Rhino. So Rhino is well known for their work in the healthcare space, but now they also work in other areas. And Rhino is helping organizations to bring federated learning really into the enterprise. There's going to be a talk tomorrow, and I highly encourage you to participate. Another announcement we made recently is our partnership with Aferis. So Aferis is a new member in the Flower ecosystem, and Aferis has been doing some great work when it comes to governance around federated learning systems so that you can safely collaborate on distributed data. Make sure to check out the talk from Chris and Jan tomorrow. Last, but definitely not least, is Octopipe. So Octopipe is working on FL operations, FL ops as it's sometimes abbreviated. And tomorrow, Ivan is going to talk about how they integrated Flower into their system, into their platform, to use it to improve the energy efficiency of data centers. Now, with these integrations, I think we hit a very critical milestone, a milestone where suddenly these systems become interoperable. You, as a user, have practically almost infinite choice. You can build your Flower app and then decide where to run it. You can run it in simulation if you're a researcher. You can deploy it via the Flower deployment engine, but you can also deploy it and run it on top of NVIDIA Flare or Intel's OpenFL. And you can also use some of these commercial platforms that exist that give you features like governance or industry-specific features that you care about for your federated learning system. Now, a great milestone we also recently hit is the open source ecosystem around Flower is just growing like crazy. We have 2,000 dependent projects on GitHub. So this is other open source projects that have been open sourced and that are available on GitHub for everyone to check out. So that's it about the Flower Framework. Flower Framework gives you capability to run federated learning in a production-grade environment. And we have an amazing partner ecosystem that you'll hear more about throughout the rest of this conference. Next up is Flower LLM, and welcome Nick to the stage to tell you more.
So LLMs and foundation models more generally is where we see AI really pushing the limits of what it's capable of. I wanted to give you an update, therefore, what Flower and decentralized methods mean for this domain of AI. And so there's a lot of results discussed in AI every single day. It's hard to keep up. But one result that you really should take notice of and will actually probably stand the test of time in terms of what's happened in the last 12 months is a breakthrough in our ability to train distributedly, a breakthrough in our ability to have physically spread GPUs and computational resources and data, and yet still have that type of apparatus, that type of system, train foundation models and LLMs. In fact, in the last 12 months, there's been a reduction in the effort and the communications needed between these resources by a factor of 1,000. And so this is a complete breakthrough because it changes the way that we will start to build and train our models and no longer requires us to have the data and the compute all in one single place. And this is a complete game changer. If you don't think, if you don't have to trust me and when I'm saying this, let's hear from someone else. Let's hear from Jensen.
Yes, 200 to 300,000 GPU clusters are here.
Yeah.
Right? Does that scale to 500,000? Does it scale to 1 million? And does the demand for your products depend on it scaling to millions?
That part, the last part is no. My sense is that distributed training will have to work.
Right.
And my sense is that distributed computing will be invented.
Right.
And some form of federated learning and distributed, asynchronous distributed computing is going to be discovered. And I'm very enthusiastic and very optimistic about that.
And so research says that we can now do this. People leading in the field of being able to put together data centers and push the envelope in terms of compute say that we can do this. And so as a result, we're going to start to do this. We're going to start to see different forms of AI infrastructure evolve rapidly now that the brakes are off. So we can now build, for example, a network of web browsers that can literally train fantastically powerful foundation models and LLMs. We can start to see sit-at-home style efforts where we have individuals putting forward their computational resources and their own data and training models in a privacy-preserving way. We can start to see the types of distributed infrastructure able to train models based on data from cars and robots. We no longer have to live in this sort of data center-centric worldview that Daniel started the keynote off with. So now that we can do this, there's a vacuum, because we need to have the types of software, the types of algorithms in order to stand these systems up. And so that's something we've been thinking deeply about at Flower. Around 12 months ago, we showed it was possible for the first time to train foundation models, LLMs, beyond the 1.3 billion parameter barrier. And so what we've done in the last 12 months is invest heavily on the types of support within the Flower framework in order to make all those different types of AI infrastructure feasible and possible. We've got a system called Photon. We've got embeddings called Depth. They run straight on top of Flower, and we have the beginnings of a brand new optimizer networking stack that will be offered in this calendar year. And when you put those things together, you can build all of the things I was just describing. It's completely open source. The various components of it have been peer-reviewed. It supports LLMs, but it's also entirely multimodal. There's nothing quite out there like it on the market or in open source today. It can even support various types of computational hardware. It's what the world needs to move forward. And so we've been using this already internally to test it out and to see what it's capable of. And so I'm very proud to announce today Flower LLM 1.7b. Now, we've used this software internally to build the first SOTA LLM that was trained using distributed and decentralized methods. Now, the emphasis here is it is a SOTA LLM, meaning that it has capabilities as measured that are equivalent to any other type of SOTA LLM model, and yet we were able to train this in a decentralized manner. And so most of the prior results in this space lag SOTA. They might lag SOTA by 5%, 10%, sometimes 20%. So while they converge and they work, they are not the best models. This is not true of this particular 1.7 billion parameter model. It has results, these downstream tasks we measure, that are equivalent to the Hugging Face small series of models. And then if you compare it to more familiar models such as Llama 3.21b, actually exceeds its performance. And again, it was trained in a decentralized manner. So again, there's nothing stopping us moving forward rapidly. And that is why I'm happy to announce Flower's last partnership of this keynote, and that is with Varna. Varna is the leader in user-curated DAOs, where users can opt in and start to build their own collective of different various kinds of data. They have a membership of 1.3 million users who have created over 300 DAOs, each with unique types of data from various sources, their cars, their homes, emails, data they have personal to themselves, and it's data that you will never find in any other type of foundation model LLM. But it's the type of information, when handled properly, when handled selectively, can provide LLMs and foundation models with capabilities we've never seen before. And so in this year, moving forward, we're going to work closely with Vana to build what we call Collective One. Collective One is the world's first decentralized, user-owned foundation model. And so each user that opts into this process and puts forward their data and then trusts us to process it well will have a stake in this model. It'll be a model, again, as I mentioned, that'll have capabilities that we've never seen before, using data that's never been used to train on before at this scale. And we couldn't be more excited to work with Vana on this. And in fact, the creator of Vana and CEO of Open Data Labs, Anna, is actually going to be giving a talk in about an hour's time to explain much more about this initiative. And I'd just want to also say that, again, this will be 100% user-owned, 1.3 million users, 7 billion parameter model that will be standing up in this calendar year. So to conclude, the age of decentralized AI has arrived finally for LLMs and foundation models, and this is the way that SOTA will move forward. Flower is the choice of platform, open source, and peer-reviewed infrastructure that people will be starting to use to build up these various kinds of ways of training these models as we move forward. We've started to work with a lot more people, a lot more organizations that I have time to mention. There'll be a talk later today that'll go and enumerate around this. But we have, for example, 2 different types of foundation models that have been trained using our infrastructure that I haven't mentioned yet. We've started to work with SprintDien, the German government, to stand up sovereign type of models that are such essential types of assets for countries moving forward. And multimodal support has also arrived. So there's a jam-packed series of announcements that relate to this direction that I'm happy to tell you about later today. Over to Daniel.
Thanks, Nick. So what we've seen today is Flower Intelligence. It's a new way to build on-device, local-first remote compute. We've seen the next generation of the Flower framework and how it enables you to bring FL to production in a seamless way and across multiple platforms. And we've seen Flower LLM. I would just say decentralized foundation models are here. A lot of this is powered and only possible through the amazing Flower community. So huge thank you to the entire Flower community. And you'll be hearing a lot more about these topics, a lot more in-depth information throughout the rest of the conference. So enjoy the rest of the conference and see you there.